Okay, we're back again. We did chapter 7 before Thanksgiving, law of signs. So we did that on last week. Remember the law of signs. And the law of signs looks like this. A over sine A equals B over sine B equals C over sine Z. So it's a proportion. We also did problems where the angle was on top. So if we're trying to find an angle, we put the angle on top. So all we do is take the original one that we looked at and just flip them all over. Now, it works pretty simple. You just cross multiply and divide, or divide and cross multiply. And it was pretty simple to find the missing side or a missing angle. Now, of course, when everything seems really simple, there's always a catch to it. Well, there is a catch to the law of signs. Sometimes, just if certain conditions are met, there are two possible solutions. So instead of one set of like two angles and a side that work, there's also a second set that work, and we don't have any way of knowing which one is the correct one. And when that happens, there could also be no solution. So when you start doing your divide and cross multiply, you'll get error on your calculator. That's when you know there's no solutions. Now, when that happens, or when you know that's going to happen, there's three things that have to be true. First, you're given side angle. So like here on this first problem here, you have angle A is 55.3, side A is 22.8, side B is 24.9. Well, if you put those on your thing, you'll notice we have angle A over here, we have side A here, and we have side B here. Well, if you look at that, that is side angle. So you know we can use the law of signs because we have a pair of opposites. We're going to find a missing angle. So that's the first thing. You have to be given side angles. So in other words, your first thing you're finding is an angle. The second thing is if the angle you're given is an acute angle. If it's not, if this angle is bigger than 90, then there's only one solution. But if this angle is smaller than 90, there might be two solutions. And the third condition is the opposite side. So here they gave us angle A, so the opposite side is A. If that side is smaller than the other side they give you, that's what this means if opposite side is less than the other side. So if A is less than B on this one, A is the opposite side, it's less than the other side. Then it has two solutions or zero solutions. So this one you can see fits that criteria. We're given side angle. Our angle is 55 degrees, so it's an acute angle. And side A is 22.8. That's smaller than side B, 24.9. So the opposite side is smaller than the other side they gave us. So this one either has two solutions or no solutions, one or the other. Okay? So if we're working that problem out, so if we look at our picture again, if I draw it again just like it was there, and you could draw the picture anyway, just have to make sure that the sides go. So opposite angle A is side A, opposite angle B is side B, opposite angle C is side C. So here they told us angle A was 55.3. They told us side A is 22.8 and side B is 24.9. Again, we were given side angle. Our angle is an acute angle, and the opposite side, 22.8, is smaller than the other side, 24.9. So this might have two solutions. Now we're going to start off solving it just like we did last week in the trials. So first, we have a pair of opposites. We have angle A and side A. That's how we know you can use law of signs. Since we're given side B, the first thing we want to find is angle B. So to set that up, we say the sine of angle B over its opposite side, 24.9, equals the sine of angle A. Sine of angle A, we know angle A is 55.3 degrees over its opposite side, which is 22.8. So we just set it up just like we always do law of signs. Now we use our calculator. Again, all of these will be in degrees, so you want to make sure your calculator is in degrees for all these. So if we work that on our calculator, we're going to take the sine of 55.3. So the sine of 55.3, we're going to divide it by 22.8. and we're going to multiply by 24.9. And I get 0.8978. So we have the sine of B equals 0.8978 or 8979. We did one just like this last week. Now, to get rid of sine, we need to do the inverse sign. So we take second sine, second answer, and it tells us that's 63.879 degrees. So angle B is 63.9 degrees. Okay? So nothing, we aren't doing anything different than we've done before. Well, now we know A and B, so if we take A plus B, that'll be 63.9 plus A, which was 55.3. That gives us 119.2, I believe. Now for our third angle, we subtract that from 180. 180 minus 119.2, let's see, that's about 120, so 60.8 degrees. That's angle C. Okay? Nothing different. Now, that's angle C. Now to find side C, that's our last thing. Now we go back to the original way we did law of sines. Since we want to find a side, let's put this side on top. So side C over the sine of its opposite angle equals the pair that we knew to start off with. That was side A, which was 22.8, over the sine of angle A, which is 55.3. Now we do that on our calculator. So we take 22.8 divided by the sine of 55.3 and take that times the sine of 60.8. I get 24.208. So side C is 24.2 and we are in feet. Okay? So we solved the one set of problems right there. So we don't do anything different there, just like we normally do. Okay, now for our second set, we go back to where we started. Here, this all comes back to when we did inverse sine before. Here, the sine of B is a positive number. Remember, sine is positive in the first quadrant and the second quadrant. Well, we put it in the first quadrant to get 63.9. But we don't know. It could have been in the second quadrant. Well, if we go over here in the second quadrant and we put 63.9 over here in the second quadrant, well, this angle here, that could be angle B. So it could be 180 minus 63.9. So 180 minus 63.9 is what, 116.1? So angle B could have been 116.1. I'm going to call that B2. So our angle B could have been 116.1. Again, it all is because here our sine was positive, and it could have been in the first quadrant, 63.9, or in the second quadrant, 116.1. Okay? Now we're going to do the same next two things we did here, only now this is our angle B instead of 63.9. So if this is angle B, well, we know angle A is 55.3. So if we had A plus B2, that'll be 116.1 plus A, which was 55.3. That's 171.4. Now we subtract that from 180. That's going to be, looks like 8.6 degrees. That is angle C2. So angle C2 could have been that. Now we need to find side C. So side C2 over, again, we'll use the law of sines, over the sine of its opposite angle, because now that's 8.6, equals our original pair, which was 22.8, over the sine of 55.3. Now we do that on our calculator again. So we divide. So 22.8 divided by the sine of 55.3. And we multiply that times the sine of 8.6. I get 4.146. So if we round it off to 4.1, 4.1 feet. That's our two sets of answers. So we did one without even thinking about anything else, just went through and find our three missing parts. Then for the second one, go back to the very first angle you found, subtract it from 180, because it could be in the second quadrant. Now go do the same steps we did before, except using that for your angle. In this case, that's angle B, using that instead of the first one we found. Okay, that's two possible sets. Let's look at this next one. Now in this next one, you see here we're given angle B is 5540, side B is 8.94, side A is 25.1. So let's take a look at that. Let's draw our triangle. So again, you can draw your triangle any way you want. Let's say we go A, B, and C. Here, angle B, this angle right here is 5540. Side B, which is across from it, is 8.94. And side A across from A is 25.1. So now if you notice, we have side angle. That's the first thing we check. So we have that. Is the angle they gave us an acute angle? Yeah, they gave us the angle B was 55. So that's an acute angle. The third criteria is the opposite side. Well, the opposite side is 8.94. Is that smaller than the other side? It is, yes. So this one might have two solutions. So let's start finding it. We have a pair of opposites. We have angle B and side B. There's our pair of opposites, so we can use the law of sines. Since we're given side A, we need to find angle A. So we say, okay, the sine of angle A over its opposite side equals the pair we know, the sine of 5540 over its opposite side. That's how we set up our law of sines. Now again, we use our calculator. So here, remember, for the sine of 5540, you hit the sine of 55 plus 40 divided by 60. We divide that by 8.94, and now multiply that by 25.1. I get 2.318. So now we have the sine of A equals 2.3184. Now to find angle A, we do the inverse sine. Well, if you're kind of really noticing things, you should know that right now what your calculator is going to say. So if I take the inverse sine, so second sine, second answer, it tells me error. Well, it tells me error because remember, can sine be 2.3184? Remember, sine and cosine have to be between -1 and +1. So this is not possible. Right? So this is not a triangle. Because the sine, remember, the sine of any angle has to be between 1 and -1, and this is too big. So this is the kind you hope for. Because when you do it, you say, oh, not a triangle, I don't have to do any more. So that's all we have to do. All right? Let's look at the next one on there. So it gave us angle C and then two sides. So if we look at that, again, draw your triangle any way you want. There's A, B, and C. So this is side A, side B, side C. They tell us angle C is 98 degrees. Side B is 15. Side C is 12. Now, if we were checking to see if this has more than one solution, notice we were given side-side angle, so it satisfies that. But here our angle is an obtuse angle. That can only have one solution. So we know we don't have to worry about two here. So if we start to find this, we have a pair of opposites, side C and angle C. We've given side B, so if we want to find angle B, we say the sine of angle B over its opposite side equals the sine of angle C, which is 98, over its opposite side. Now again, if we use our calculator, so we take the sine of 98 divided by 12 and multiply that by 15, I get the sine of B equals 1.2378. Well, again, if you think what we talked about in the last one, here if I do inverse sine, it's going to say error again, because remember, sine can't be bigger than 1. So if I take second sine of second answer, it tells me error. And this is because here, the same thing is called the triangle inequality. The biggest side is always opposite the biggest angle. Well, here, if angle C is 98, there can only be one angle bigger than 90. So it doesn't, if angle C is the biggest angle, doesn't side C have to be the biggest side? But notice it's 12 and side B is 15, so this is impossible. Okay? So just going back to that first one we did again, just a reminder. So we had side angle. We were given an acute angle. Here it was 55.3. The opposite side, A, was 22.8. The other side was 24.9, so it's smaller. So this might have two solutions. So we first did it, found the three missing parts without even thinking about a second solution. For the second solution, we go back to the very first angle we found. We subtract it from 180. That's our second option for angle B. Then we went through the same steps. Well, we had angle B and angle A. We added them together and got 171. We subtract that from 180, so our third angle, angle C2, had to be 8.6. Then we need to find the side opposite angle C. So that's the side opposite C2. We put that over the sine that we just found, equals a pair we had in the beginning, and then we just used our calculator and found our second set. And that's it for the second part of law of sines.